In this video tutorial, we're going to design a synchronous data path multi-cycle neuron design. So we're going to introduce the registers to our input of the axon and synapse, and then we're going to have a 2-bit ring counter to control the registers, and then we're going to have a register to the output 2 for the Y, and then we're going to have a counter, 4-bit up counter, which will count the amount of the result that will present out. And then we're going to have the input start and the clock. So let us design this in Quartus. Now the first thing that we're going to do here is to create a new Verilog file. And then we're going to save it as Neuron. So the first thing, we're going to design the module. So we're going to call it module name Neuron. And then we're going to have our inputs and outputs. So we know we have start as an input, and then we have clock. Those input are here. So you can see we have input start clock, and the W and X, those are inputs, and the output Y and the output of the up counter, which is 4-bit. So we have start and clock, and then we have X1, X2, and then we have W1 and W2, and then we have Y, and then we have count, and then we're going to close this module, end module, and then we need to declare our inputs. So input, so the first we start with the 1 bit, so it's start and clock, and then the input, which are 4-bit. Since this is parameterized, so we need to declare, for example, the parameter first of all, because since it's parameterized, so you can say parameter. So we have parameter n, we can set equal to 3, and we have parameter q and equal to 2. And then here, so our first input that we're going to declare now is the x1 and x2, and all of these are 3 bits, and we have input W, W1 and W2, and these are of 2 bits. And then next we're going to declare our output. For Y, and we know the answer of the Y, it is the max we can get, it is 3-bit 2. And then we can have last the output of the counter, and we know the counter is the counter of 4-bit. And then what we can do next now it is to instantiate our registers. So first let's open the registers. So n-bit register, and then open the ring counter, up counter, and let's open the neuron core. So let's instantiate our n-bit register. Here. So the first thing we instantiate the n-bit register. And then the first register is for example, we can say this is for W1. So it is this register here for W1. So what we can say here is the input of the register is W1. And then we have the clock, which is the clock, same. And then we have this load here, which it's controlling the register. This one, you can see, which is the output, the second bit of the ring counter. So we can declare here it is the second bit of the up counter, and then we need to declare here as a wire. This is 2 bits, and this the control of it, of the register. And then next is the reset, and the reset here it is, we're going to use start to reset our counter. And then the output of the counter, it is a wire again, so we can declare it as a wire, for example, wire. And we know the output of the register is the same as the input, so it is Q minus 1, which is 2 bits. So we can call it register W1 and register W2. And then here the output of the register is RW1. And then what we need to do next, we need to define the parameter of the register, because now it is 2-bit register. We need to write def param. For example, we need to give it this one a module 2 name, so we can call module 1. So def param of the module 1, and then it should look for the n parameter and set it to equal to Q. And then what we can do next, it is just copying this one again, X1, and then we have clock, load, the same, start, and now we need to write X1 and change the parameter to n, since this one now it is 3 bits, and then module name M2, and here M2 again, and we need to declare the X1 register, the wire of it, and X2, and those are of 3 bits. And then next what we can do again is do for the W2 and X2. So we can say this is module 3, and then this is W2, W2, and here module 4, X2, X2. So now we have finished with this line here up here. We have instantiated the registers and we have controlled it with the ring counter and the input start and the clock. Next, what we can do is to instantiate the ring counter. So we can go to our ring counter and copy the ring counter here and insert the ring counter. So we can give it as a module 5. And then we have the input is clock, start, and then the output of it is this one here, which is controlling the registers. And then we need to define the ring counter. Since this ring counter it's only of 2 bits, so we need to write def param of module 5, look for the n parameter, so we need to write n is equal to, now it is equal to 2. And then next what we can do now is to instantiate our neuron core. And we can give it module 6. And then we know the inputs of the neuron core, they are from the registers. So x1, it should be register x1, register x2, and register w1 and register w2. And then we need to declare, we know this is the same as y and it is the 3-bit, so we can write it here. And we need to write it here, register y. And then what we can do next is to instantiate another register. So let's just copy this register here, and this one is for the y. And then we can give it a module 7 name, and then should look for the module 7, and we know that the register here is 3 bits, the output of it, since the input of this register, it is register y, and then we have clock, and it should be controlled by the first bit of the ring counter, which it is this register here, and then it is start, and the output of the register, it should go to the output y, which is this y here, the output y. And then we need to have we need to instantiate our last module, which it is the n-bit up counter. And then this counter, it have the input clock, and the control of the counter, it is the output of the first bit of the ring counter, and the reset of it is start, and the output it is counter, which is this one here. And then we need to declare the n-bit up counter parameter. This is a 4-bit counter, so we need to write def param of module 8, and it should look for n parameter, and it's equal to n plus 1 since it is 4-bit. So let us save this file and set it as top level entity and try to analyze and synthesize to see if we have done everything correctly. We can see that we have some errors here, so let us check it. We have a warning in line 25, and then we have error in line 2. Okay, so it's count, not counter, it's count. So, and then we need to remove count. And then we have a warning what is on line 25. It is start. It needs to be a capital letter, start. So let's save it and try to analyze and synthesize again. So we have successfully analyzed it. On the next video, we will try to generate a test bench file for this to see the functionality of it.